So, in this video we are going to discuss quadratic sequences. We've already discussed arithmetic sequences in previous videos, and we said that an arithmetic sequence, to identify it, we are going to look at the difference of the sequence, and if we find out that the difference is common, that difference between each term is the same, the first difference, we know that we are dealing with arithmetic. Now, let's take a quick example of that. If we have 1, 2, 3, 4, and 5 as the terms of our sequence, if we want to find the difference between these terms, we are going to subtract the following term with the previous term, the following term with the previous term, which will give us 1. Now 3 minus 2, following term, subtract the previous term, gives you 1. And we keep going and going. Now, because this difference between each term is the same and is the first difference, we know that this sequence is arithmetic. Now, an arithmetic sequence, or rather a linear sequence, is one where you find that the first difference is common. Now, let's say using the same sequence, this arithmetic sequence, let's see if we can find a higher sequence where this arithmetic sequence is actually our difference. Now, let's say our first term is also 1. Now, remember, to get the next term, we are going to take this term and then add it to a common difference, not the common, just the difference, to find the next term. Just like we did here, 1 plus 1 is 2, 2 plus 1 is 3. So 1 plus 1 will give us 2, 2 plus 2 will give us 4, 4 plus 3 will give us 7, 7 plus 4 will give us 11, 11 plus 5 will give us 16. Now, this is the higher sequence that we find, whereby the arithmetic sequence is the first difference. The interesting thing about this now is that if this is the sequence that we are trying to deal with, this common difference is now, it is not the first difference, it is now the second difference. And when a sequence has a common second difference, we say that sequence is a quadratic sequence. Now, in any quadratic sequence, the first difference will be arithmetic, and then the second difference will be common. And if we didn't have this sequence, we were just dealing with the arithmetic sequence, then the first difference to the arithmetic will be common. The second difference, 1, 2, to the quadratic sequence is common. Let's say we have 1, 2, 6, 13, 23. Let's say we are given this and we are told that we need to determine what type of sequence is this. Now, so far, to check what type of sequence we have, we check the difference. Now, let's do that here. To find the difference, we take the following term, we subtract the previous term. So 23 minus 13 will give us 10. Now 13 minus 6, the following term, subtract the previous term, it will give us 7. 6 minus 2 will give us 4. 2 minus 1 will give us 1. Now, we found the first difference, and we find that it is not common. So we know that this is not an arithmetic sequence. But what will happen if you find the second difference? Now we do the same thing. The following term, subtract the previous term. So 10 minus 7 will give us 3. 7 minus 4 will give us 3. 4 minus 1 will give us 3. Now, we have our second difference now, and we find out that our second difference is common. Therefore, what we have here is a quadratic quadratic sequence because we found out that not the first but the second difference is common. So therefore this means that this will be an arithmetic sequence and this will be our common difference. Now, in our arithmetic sequence video, we said that the common difference is denoted as D, but that D is only for the first common difference. If this is the second common difference, let's just call it the second common difference. We don't use D for that one. Now, what do we mean by quadratic? When you go back to functions, you remember that to draw a quadratic graph, a quadratic function, you will remember that your f at x will be given by ax squared plus bx plus c. This is a quadratic function. Now, even when we're dealing with the quadratic sequences, we're still visualizing the same type of function. Now with the arithmetic sequence, you remember that we found that our Tn was 4n plus 19. It was minus 19, it doesn't matter. Now if you look at this as a function, you will know that our f at x is just some gradient variable plus c. So it was a linear function. If we drew the points on the terms on our sequence, we will find that they follow a linear function. But with a quadratic sequence, we found that our terms will follow a quadratic function. If you want to visualize it, it looks something like this. Now, how do we find this nth term for a quadratic function? The same way a quadratic function is given by ax squared plus bx plus c, our nth term is also given by a, but now we are looking for an nth term. So the position will be denoted by n plus b. Our x is now an n plus c. And this is what gives us the general formula for the quadratic sequence. The general formula for nth term of a quadratic sequence. It just looks like this, but now we are looking for the nth term instead of drawing a continuous function. Now these are discrete points, so our graph will actually be something like our first point, our second point, our third point, our fourth point, our fifth point. They will go like this, but they would follow a sort of quadratic function type of shape. Now what I'm going to do now is for us to see how do we get this general formula from our sequence. You might remember that from arithmetic sequence we said that our first term is denoted by a. However, in a quadratic sequence, our first term will not only be a, we will add both a plus b plus c. Our second term will be 4a plus 2b plus c. Our third term will be 9a plus 3b plus c. Our fourth term will be 16a plus 4b plus c. Now, once we have this, our terms in a quadratic formula, remember that this is our first term, our second term, our third term, and our fourth term. These are the formulas for the terms in a quadratic sequence. Now, a plus b plus c is a plus b plus c. 4a plus 2b plus c. It is the same that you find in your general formula for the nth term. But since we do not have it, we are going to see how do we find it. Now, the first step in any sequence, we'll try to find the difference of the terms. Now, the difference, we take the following term, subtract the previous term. You will find out that the first will give us 3a plus b. You can see that 4a plus a, 3a, 2b minus b, b, c minus c is 0. Now, let's keep continuing just like that. 9a minus 4a, it will give us 5a plus 3b minus 2b is plus b. C minus c is 0. And then we keep going. I'm just simplifying so that we do not have to use up all our space. You can check them yourselves that this term subtract this term. This entire term is just term 1, term 2, term 3, term 4. Now, the last one here, 16a minus 9a, it will give us 7a plus b. This is our first term, first difference. And we can see that there is no way that these are the same. So we know that, okay, this is not an arithmetic sequence. But let's find the second difference and see if that one will be common. We go with the following term, subtract the previous term. 5a minus 3a, it will give us 2a. b minus b, it will give us 0. So we have 2a there. And 7a minus 5a is 2a. b minus b is 2a. So we can see that these are equal. So the second difference is common. So therefore we know that this is a quadratic. This sequence in black is a quadratic sequence. Now, this is what we are going for. This is the formula that we are going for. Now, to find the nth formula, the general formula for the nth term, we are only going to focus on these three. I want you to only focus on these three if you are in K12. If you have a good memory as to how these numbers, because I had to check again and check to remember these terms. You can use also these, but I want you to only focus on these three. The second difference, the first term of the second difference, the first term of the first difference, which is the arithmetic sequence, and the first term of the entire quadratic sequence. Now, what we're going to do is now find the nth term for this this sequence here that we already used to explain our concept. Now, what we're going to do is 2a in our sequence will be equal to 3. Now, you do not have to always write this entire thing down. Once you have your differences and your second difference, just remember that by using these first three values, you will know that the second difference is 2a, the first difference is 3a plus b, and the first term is a plus b plus c. Those ones you need to remember in your head when you're in an exam. So our 2a will be equal to 3. This is where we have 2a, 3a plus b, and a plus b plus c. So 2a is equal to the value of 3. So our a will be 3 over 2. Divide by 2 on both sides. Now, what about 3a plus b? 3a plus b, if you also look at this sequence, we'll see that it is equal to 1. But we've already found the value of a, so we're going to put that in here. which is 3 into the value of a, 3 over 2 plus b is equal to 1. We now make b subject of the formula. B will be equal to 1 minus 9 over 2, which is minus 7. Now, this is our value of b. Now, we start here, we come here in this direction. We start here, we come here, and then we end up there saying, okay, what about a plus b plus c? Our first term of the quadratic sequence, there it is given by 1 also. Now we already have the value of a, which is 3 over 2 plus b, the value of b, minus 7 over 2 plus c. And then we make c the subject of the formula, which is going to be 1 plus 4 over 2, which is 6 over 2, which is just 3. So c is equal to 3. Now, once we have a, b, and c, we can now put them in the general formula for the nth term. We have a, b, and c. Therefore, our nth term will be the value of a is 3 over 2 n plus the value of b minus 7 over 2 n. This is n squared. And then the value of c will be plus 3. Now, this is the general formula for the nth term for this sequence. And every time you are given a quadratic sequence, you are just going to use that method that I just used to find the nth term, the general formula for the nth term. Let's just text it quickly and see if we can find term number 3. 1, 2, 3. N minus 3. Remember, n is the position in the sequence. So T3 would be 3 over 2, 3 squared, substitute 3 in every position of n, minus 7 over 2 into 3, plus 3. Let's simplify. Well, 3 over 2 into 9, minus 7. 7 times 3 is 7, 14, 21 over 2 plus 3, which is 6. And we see that term 3 is equal to 3. So that's how you find the general formula for the nth term.